Okay, I think I'm live. Let me share my screen with you all. Yeah, so we have solved the lead code problem of the day. Now it's time for Geeks for Geeks. So I think every one of us have heard about this problem statement, which is Coco eating banana. I think I have solved it previously on lead code, but let's look at this problem statement also. Coco is an given array where each element represents a pile of bananas. She has exactly k hours to eat all the bananas. Each hour, Coco can choose one pile and eat up to s bananas from it. Okay. If the pile has at least s bananas, she exactly eats exactly s bananas. If the pile has fewer than s bananas, she eats the entire pile in that hour. Okay. Okay. Uh, Cook can eat only can eat from one pile per hour. Okay. Your task is to find the minimum value of S such that Cook can finish all the piles within k hours. K is 4. Okay. 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 Yeah. All the bananas. Hmm. Do we need? Okay. This is the problem statement, right? We need to search the optimal approach, right? So, suppose this is the example that we have 5, 10, 15, 20. Okay, 5, 10, 15, 20. I'm talking about the brute force approach. Okay, now we need to find the minimum value of S. K is equal to 7. Okay, and we'll start from here. Let's K is equal to 5. Okay, after that, we come to 10. Okay, let's K is equal to 5. Okay, the value of the answer should be like minimum it can be 5, maximum it can be 20. It cannot exceed these values, this is for sure. So here we can get an idea that it is kind of a binary search problem, but let's see. Okay. So minimum is 5, maximum is 20. Like we can do one thing, we can sort the element or something like that, but let's see. We'll start from 5. Okay, it is in sort order, so it's good for us. Okay, so let's go. We'll take 5. Any other example? No. Okay, we'll take 5. After that, it's 10. So in the first hour, we'll decrease k is equal to k minus minus. Okay, one thing we can do, we can just increase in the brute force approach. We will start from 5 and we'll go till the maximum of all the elements. Okay, and we'll decrease every element by that, and as soon as we'll get the answer, we'll just return that answer. Okay, what I'm trying to tell is, so the solution that I come up with, the brute force solution, that for auto and x variable are maxi is equal to max of maxi comma x. Same mini is equal to minimum of mini comma x. Great. About maxi and mini mini int max. Okay. With this, we can get the maximum and the minimum element. Now, for int I is equal to I is equal to I is equal to mini, comma, I is smaller than e to the power of size, I plus plus, no, no, sorry, not e to the power of size, I is smaller than equal to maxi. Now, uh, what I'm going to do is, I'm going to check for each and every element for int j is equal to 0 to j is smaller than a to the power of size j plus plus. Okay. Also keep int temp is equal to k. Okay. Now, uh, what I'm going to do is I'll just simply check that just simply check. Okay. Mm, a double r mm, 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 just simply decrease the element with that and see if it is possible or not. Right. Oh, it is going to take too much time to just write all those things, but still, mm, let's keep a variable vector not visible variable or let's just write it. Okay. Mm, nums of I'll create this nums. So it is going to take O of n like space complexity also every time. So I don't think this solution is going to work. This is a very lengthy solution also. I don't prefer this solution, but still, the main thing, the main idea that I come up with is research. Okay, so like I told you, the minimum is can be 5, the maximum can be the max element here. Okay, so what I want, I'll just calculate the uh, total time it is going to take to eat the bananas for each and every middle element. Let me show you how I'm going to do this. 5, 10. Suppose if okay, okay, no issues. Okay, great. While mini is smaller than maxi, what I'm going to do is int mid is equal to um, maxi minus mini, maxi minus mini by 2. Okay. Now I'll just check a double r comma mid comma k. Okay. I'll write the check. Answer is equal to mid. If this is the answer is equal to mid. Max is equal to mid minus 1. That's all. And if this is not the case, we'll just increase the value of mini. That's all. Okay, great. Now what? We just have to write this check function and here return answer. Also answer is equal to, let's answer is equal to 0. Okay. We'll check. comma and k. Okay, so this is the soul of the problem. Okay, and what we are going to do is in this we'll calculate all the hours that we took to like the time it is going to take for the Koko to eat that banana in that for that mid range. Let me show you how. Int hours is equal to 0 for I smaller than regular size I plus plus. Okay, what we're going to do is going to take hours plus is equal to nothing but a double r of I plus med minus 1. That's all. Divided med. Return r smaller than equal to k. Yeah. So this is what we were checking for each and every element. But rather than for each and every element, we know the mid and max, minimum and maximum. So we are going to do this. That's all. Okay. Okay. Minimum is int man. Max is equal to minimum of minimum x. Maximum x. Okay. 10 and 3. This is the answer, right? Max is equal to minus 1. Answer is equal to 0. Check 10 and 3. Yeah, this is okay. Till there, they are right. While minimum is smaller than equal to maximum. Mid is equal to maxi plus maximum is equal to high plus high minus low, right? Okay. Check. Okay, nice. It is working perfectly fine. Let me submit this code now. Okay, that is giving me wrong answer. The correct answer is 1 for 3 and 4. The hours are 10. For 3 and 4, the hours are 10. The minimum hour in 1 hour, she can eat 10 bananas, right? Acha, she has exactly k hours to eat all the bananas. The pile has at least 8 bananas. She exactly eats 8 bananas. If I have fewer than 8 bananas, she exactly. Acha. Hmm. Okay. So, okay. Then it is going to be 1. Okay. And we cannot, this is not necessary. Let's see now. So this time it should work. No. Maxi, sorry. Not Maxi. It's mini. Is equal to 0 and remove the mini. Okay. Now let's see. 0 or 1 we can take. Okay. It is working fine, I guess. Yeah. Let's submit this code and see. Yeah. Passed all test cases. So okay. Thank you so much for watching.